Hello, I'm Jawad Rahimi from Kabul University in 2024, and in this lecture or in this video I just want to talk about one of the most important sorting algorithms. So as you know, we have a lot of sorting that is very important to understand, but some sort algorithm is very important that is going to be preferable to understand for the first time and then go to the next source. In this lecture, I'm gonna talk about the stock sort. So before to start the stock sort, I'm gonna define or introduce myself. As you can see, my information is about in the bottom of the lecture, in the bottom of the page. As you can see, my full name is Engineer Jawad Rahimi, and in this first semester in the faculty of CSSE. So this is gonna be presented by the CSKU group of Kabul University. So I'm gonna talk about the stock sort. So let's get started if you are ready. So in this lecture, I'm gonna talk about the definition, approach, and explanation, illustration or analysis, time complexity, space complexity, and implementation of the stock sort. And about this stock sort history, I'm not sure about that. We're gonna talk about that, but let's get started. So what is stock sort in here? Stock sort is a recursive sort algorithm. This kind of paradigm that recursively, return recursively based on a base case and recursive case. As you can see in here, it is slower than the bubble sort. We know the bubble sort is one of the worst sorting as an iteration, based on iteration. It has a lot of iteration, but the stock sort is slower than the bubble sort, but it is very bad algorithm, as you can see, because it has a lot of swapping and iteration, so it's gonna be very bad. And our last sort, which is interesting, as you can see, it's very interesting. It's suitable for any people because it's just swapping between the first and last element of the partitioned list, as you can see, and I will define what's the partition in here. For the first time, or the first step of the algorithm, if the last value is less than the first value between, and it will be swapped between them. So it is the base case of the recursive algorithm to check if the first value of the list is less than the last value, it will be swapped between them. Okay? I'm sorry. If the last value of the list is less than the first value, we will have to swap between them. Okay? And go to the next step. Maybe in the base case we have a list and a length of 1. So in here it's not too recursive. It just not need to recursive. It just not need to partition your list for the first time. If the first and it just check the first and last element. But when you have the subset, or when you have more than 2 integer lengths of your list, so in here you have to create a subset from the whole set. So how you can create a subset? You just create the two-third first element, and then to the next two-third next subset of elements. For example, you have to divide the two-third element of your list, and then check the first and last element. If you sort it, then go to the next step of this sort or this subset, and then go to the next step recursively, and just divide it in two-thirds part. And then if you divide it to the two-third part, you have to put the base case. If the first element is bigger than the last element, you just have to swap them. And if you know this, and it will be no swap between them, and it will be no check of that. Okay, as you can see here, I will create an animated state or animated shape in here. So for the first step, we have to check the first and last element between them. If the first element is bigger than the last element, we will swap between them. As you can see here, we will be swap between them, and we can compress based on the compression. I will be swap between them. Go to the next step. So in here we have sort the first or the left two-third part of array, and we will create a subset of array in two-third part array. We will create the first to top part. Okay, as you can see in here, and I will show you in here. Yes, in here as you can see from the in here. Okay, we created the two-thirds part of array as a left side of your list. It is the two-thirds part of the left array, and then we go to the when we created this two-third part of the left array, we will check as a recursively between the first and last element, and we will be swapping between them. And then we go to the next step, it will be sorted between them, and when we go to the next step, and it has two steps, we will go the first time to the two-third part of the left array and go to the right two-third part of the array, and we will create the subset as the right side. Okay, and we will sort it between them based on the first step as defined for you. So we will sort our list based on the best case and based on the two state. Sort the left two-third array and sort the right two-third array. So this is source code in PyCharm, and in this step I just created, it means a graphical display, graphical, it means the presentation about this structure. As you can see, the final structure, it will get an array, and the first left side and the last, it means j is equal to the none. If j is none, we will j the length array of the minus 1. It is the last part of the array, the last element of the array, and I is equal to the first element of the array. So we will check if if the first element of the array bigger than the last element of the array, we will swap it in them. Okay, and then go to the next step. If j minus 1 plus 1 is bigger equal to 3, if it means if we have more than 2 length of our array, we will create a sub array based on this recursive, and we will create j minus 1 plus 1 is equal to 3 is called a two-third part array, and we will be passed in a recursive algorithm by calling its function. So this is going to be array and ij minus k. It means we will create the left side two-third part, sort the first two-third part of element, and then sort the last two-third part of element, and then we'll pass. Then go to the first step and left side we will sort it, and then we will return the array. Our arrays will be sorted in here by the recursive and by the step of the condition in here. As you can see, we have two conditions. The first step is best case, and the last step is, that means we will check if our length of list is bigger than 2 or 3. We will be it means break down our list in two-third left and two-third right side. So, and I'm gonna go to the time complexity and space complexity. The time complexity, it means it does refer to the time, it does refer to the any time that an algorithm will take to it means to to process, to to do a work, to do a process, to do a task based on the CPU processors. And average complexity is O(n). O(n), it means O(n)(2), and best case is O(n)(2) also, the worst case is O(n)(2). But the space complex O(n), when it created for the first time this array, it will take O(n) time or n space. So it will be implemented by Matplotlib, but I'm not gonna talk about that because I haven't showed for you. I haven't showed its source code, and it does not need to go to the writing code because it's not necessary. I'm just talk about the theoretical information about the structure. and maybe I have some common question about sort. And the first question is it firm in place sorting algorithm? So what is in place firm sorting algorithm? In place firm sorting algorithm, it means any algorithm that just not, it means that just not check two same value if they are at the same level, if they are at the same, it means value, and it just not check between them, and it just not swap between them. It is called in-place sorting algorithm. Yes, this is one of these algorithm, or one of kind of that algorithm. The first and the second question is about what is your paradigm algorithm. As I can say that at the first time or at the starting of my lecture, it is a recursive algorithm. So the third question is what is the two-third part and explanation part. As I can say for you, if we have more than 3 length of our array, so we need to break down our subset in two parts, two-third left and two-third right, and we'll be passed the recursive and we sort based on the base case of that recursive. It is called two-third part. And then first question is about in which kind of size we can use it. You know, in large size we cannot use it because it has a lot of iteration. When you have about, imagine when you have 100 length of size of your array, it will be take a lot of time, about approximately 10 minutes to complete sorting your array. And it is very versatile, and it's very versatile on the bubble sort, one of the worst algorithm time complexity because it has a lot of iteration, but it is slower and versatile than the bubble sort. So thank you for watching. It was my first lecture about the data structure algorithm as a sorting algorithm of data structure in first semester of College University. Thank you very much.